Good morning, geometry classes. We are looking at 11.1 samples right now from our first lesson in our chapter dealing with measurements of areas and surface areas and volumes. So we're going to start by taking a look at sample 1 where we're finding the length of AB. How far is it from here to here? We know that this arc here measures out at 90 degrees, but the question is how long is it from A to B? So we're going to want the measurement answer to that. So to figure out the answer to how long is it from A to B, what is its length, we're going to set up a proportion. So we're going to set up a proportion so we're always comparing the part to the whole. So I'm going to start over here actually on the right hand side. The part we're interested in is this 90 degree angle here for this measurement of the arc, 90 degrees, and we're going to compare that to the entire circle, which of course has a measurement of 360 degrees. That's our part to our whole, 90 to 360. Now the part that is represented by the 90 degrees, well, that part is the length of the arc AB, and that's what we're trying to figure out, so that's our variable. And the whole is the circumference of the circle. Well, the circumference of the circle we can figure out by remembering the formula. The circumference is pi times the diameter. We're given the diameter here, so that's why we're choosing the formula pi d. And we are going to plug in 6 for the diameter. That's where this pi 6 comes from. This is representing the circumference of the entire circle. All right, at that point, once we have the proportion set up, we're going to go ahead and solve for the length of arc AB. So we're going to use cross products. So 360 times our length of the arc AB is equal to the other diagonals product, which is 90 times pi times 6. And then we're going to divide both sides by 360, and the length of arc AB will be whatever 90 times pi times 6 divided by 360 is. At this point, you can throw all of this in your calculator if you want, or you can do some simplifying, which I chose to do here. I would prefer to work with smaller numbers in my calculator if possible. So I went ahead and reduced 90 over 360. 90 divided by 90 is 1. 360 divided by 90 is 4. And so that's going to give me the arc length of my AB. The other reducing that I did to get from here to here, 6 over 4 does reduce down to 3 over 2. That's as simple as that fraction can be. And so I'm going to multiply 3 times pi, divide it by 2, and on my calculator it will show me 4.71. Now you'll get the same answer if you multiply 90 times pi times 6 and divide that by 360. So either way, you can either do the reducing if that looks like it's an easy route for you, or just throw all the numbers in your calculator. We're always rounding to the nearest hundredth unless we're told otherwise, and since again on my calculator all I see is 4.71, I'm done with sample 1. Sample 2. Now I'm trying to determine the radius of the circle. So I've drawn my circle and put the question mark on R. That's what I'm trying to figure out. I will still write a proportion showing part to whole. The part that is labeled here that I'm going to start with is the 44 meters. That's the length from R to S. And the whole that I'm comparing that to is the circumference of the entire circle. How far is it around the entire circle? So this arc to the entire circle, 44 to 2 pi r, which is the formula for the circumference of a circle, knowing that I'm going to be solving for r. And that's going to be equal to the part that I'm working with. That's the 165 degrees. That's the measurement of the arc RS, and that compares to the entire 360 degrees for the full circle, and the full circle, of course, when we're looking at their circumference, is 2 pi r. Right, so we have our proportion set up. Using cross products, that will give me 2 pi r times 165. That's this diagonal. That's the product of this diagonal, and then the product of this diagonal will be 44 times 360. So at that point, if I want, I can say r is equal to in my calculator, 44 times 360, that's this, divided by 2 times pi times 165. That's what's on the bottom here. So that gets r by itself, dividing both sides by 2 pi times 165. So if I want, I can do in my calculator 44 times 360 divided by 2 divided by pi divided by 165. Or you can go ahead and do some simplifying before you put those numbers in your calculator. I divided 44 and 2, I got 22 over 1. And then I divided 360 and 165 by 5. To divide by 5, it's dividing by 10 and then doubling it. So dividing by 10, 360 divided by 10 is 36. Double that, get 72. You can always divide by 2 using that process. Divide by 10 and then double your answer. 165 divide that by 5, and I'll have 33. Again, I can think, what's that divided by 10? 16.5. Double that, and that gives me my 33. And then I decided to do some more reducing because I can. I notice that both 22 and 33 are divisible by 11. So I divide by 11 and get 2 over 3. There we have it. And then my final step in simplifying is dividing 3 and 72 by 3, giving me 1 and 24. So simplified, that gives me r is equal to 48 over pi. I use my calculator. And then on my calculator, I saw a bunch of digits. And I'm going to round that, of course, to the nearest hundredth. So that 8 is going to become 9 because the 6 has us round that up. So my answer radius is 15.29 meters. But again, if you prefer, you can put 44 times 360 divided by 2 times pi times 165 in your calculator, and it'll give you the same answer. Be careful when you are doing the dividing here. 44 times 360, divide by 2, then divide by pi, then divide by 165 to get the answer. The other way to do it is work out 44 times 360, work out 2 times pi times 165, take that answer and divide it into whatever 44 times 360 is. So sometimes you need to be a little careful on your calculator when you're dividing multiple factors in the denominator. All right. This is sample 3. This one is asking us for the circumference of this circle. Again, we're going to use our proportion setup, part to whole. We know that this part of the circle's length is 4.19. We know the circumference is the entire length of the circle all the way around. So notice I'm not using 2 pi r here because I don't need to. I'm asked to figure out the circumference. The circumference is 2 pi r, but it will be easier for me just to write c here because that's what I'm looking for. And then the part of the circle that represents this arc measurement is 40. The entire circle all the way around is 360. Then I'll use cross products. 40 times c is equal to 4.19 times 360. Then divide both sides by 40. If you want, you can put into your calculator 4.19 times 360 divided by 40. I prefer, again, to use smaller numbers where possible, so I went ahead and canceled the 40 and the 360. 40 divided by 4 is 1. 360 divided by 40 is 9. And then all I had to put into my calculator was 4.19 times 9, or actually I could multiply that out pretty easily mentally as well. But either way, we're going to find the circumference as 37.71 meters. We're already rounded to the nearest hundredth, so I'm done. Circumference is 37.71. That concludes our samples for this lesson, so it's time for you to make sure this is in your notes and move on to the quiz for 11.1. We'll see you next time.